Yesterday, we spoke about exponential growth and decay in a standard form. What we're going to do today is we're going to continue along the same pattern, but we're going to deal with compound interest as we go. The difference between compound interest and just your simple interest is on compound interest, you are also getting interest on the money that you earn. There's two forms of that, and we'll talk about that right away. We're going to take a look, first of all, at our notes. So if you would, get those out and be ready to write down this first bit of notes that you need to have down. Those of you that have had personal finance should be very familiar with this first formula that we have here, and that is our periodic interest formula. So let's take a look at this real quick. You can write that one down. There we go. A equals P, which is the principal amount, times 1 plus the rate divided by N, which is the number of occurrences, to the NT power. Give you a second to look at those. Little fuzzy there, but that is the NT power. See if we can clear that up for you just a little bit. That is, again, the NT. That is the NT power. To the NT power. And remember, just like yesterday, we've got to make sure that our rate is written in a decimal form. We're going to have a percentage rate, but that percentage rate cannot be written as a number or as a percentage. We have to move our decimal place over twice. So you see, A stands for the balance in the account after the amount of years that we are seeing. And then P is our principal amount. That is our beginning amount in the account. R is our annual interest rate as a decimal. And N is the number of times the interest is compounded per year. And then T is time, the amount of time in years, that is. So we'll use different words. We'll use the words like quarterly, that's 4 times a year, monthly, bi-weekly, all of those different things. Remember, there's 52 weeks, 52 weeks in a year. A lot of times people won't consider that. They'll think, well, 4 weeks times 12. No, there's 52 weeks in a year. So bi-weekly is going to be 26 times. All right, and then the second formula, like we see here, is the continuous interest formula. This is, in case you have a hard time seeing that, A equals principal Euler's number to the rate times time power. A lot of times you'll hear me call that the PERT formula because it's spelling out the word PERT. P stands for the same thing it stood for in the other one, the principal amount. R stands for rate. T stands for time. And then E is Euler's number. It is the number 2.7, blah, 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 blah. So we go right there. What continuous interest is and continuous compounding is what bacteria do, for one thing. As soon as the bacteria reproduces, it immediately is reproducing again. There's no gestational period. It's immediately reproducing. So it's what's called exponential. It's all exponential growth, but it's Euler number, and it's growing at an incredibly fast rate. 2.7 something is the base number. That formula is actually much easier to use, but a lot of students overlook when they're supposed to use it. So let's just highlight that word, continuous. Continuously compounded, continuous interest. What we're going to look at is how compounding differs from example to example. First off, we're going to do annually. Technically, this formula is the same formula as we did yesterday. We're going to write it down here again. The investment is equal to the principal times 1 plus or minus, because there's compounded, but we're going to compound interest. So this is going to be the rate divided by the number of occurrences per year to the number of occurrence per year times time power. So this technically is the same formula as yesterday, but on an annual basis, n is equal to 1. So r divided by 1 stays the same down here, and 1 times t stays the same. So, I mean, technically it is the same formula, but we didn't want to substitute in the number 1. But let's go ahead and put this formula together and then see what we get. And I'm going to go ahead and write it as a value of 1, but please don't do this when you're doing it for yourself. So our initial investment is $5,000, our principal, excuse me. 1 plus the rate of this thing is 0.12 divided by 1 to the 1, and then we are going to do this for 8 years, so it's 1 times 8 power. So we can put this straight into our calculator, but let's just go through and construct all our equations and see how this compounding works for us. So only thing that's going to change as we change the number of compounds is the number that we divide by and then the number we multiply by in the same regard. So what we're essentially doing with monthly is we are splitting that interest up. We're not paying it all at one time. We're paying 1% of it at the first month, and then we're going to pay 1% at the second month, and we're going to pay 1% at the third. We can make this bigger, sorry. And so on and so forth. You get the idea. So we are getting 12%. Monthly is going to happen 12 times a year, so that number is 12. And then in our numerator, it's going to be 12 times 8. Again, we're just going to fill out all of our information here. So semi-annually means twice. Think of a semicircle, half of a circle, so it's going twice. So it's going to be $5,000. We are still getting the 100% of our money times, or divided by 2 to the 2 times 8 power. And then quarterly, we're getting our $5,000. We're still getting our 12%, but we are dividing it 4 ways. So we're going to get 3% of our investment every 3 months. So this will be 4 times 8. And you're welcome to use parentheses in your exponent there. And then continuous compound. 5,000. Euler's number, there's the P, E. The rate is 0.12, and the amount of time is 8. So we'll take a step back and look at all of our different formulas. These are how we construct all of our different formulas. Now, understand this. When we are doing these values, we are not doing anything different if we give these to the bank, and you're going to see what you're going to want to do. Are you going to want it compounded frequently, or are you going to want it compounded less frequently? We'll see how this turns out. So first off, let's do basically this is called simple interest for this first year. It's the formula we used yesterday. If we did this interest, we're going to end up with, after 8 years, $12,000, yeah, $379.82. 81.5 would round up to 2. I would suggest for you guys, as you do these, use the second entry to pull your answer down. Also, I would use the alpha F1 keep from making too many mistakes here. So I'm going to do these in letter order this time, and we'll see how these numbers climb. So I'm doing the semi-annually here. And what it looks like in my calculator, I actually do it this way. I put the 8 in parentheses, but I use the same thing. I use the same formula. So again, we're not doing anything differently. The bank is just giving us interest at different times. So if it's compounded semi-annually, twice a year, you're making almost $400 more. And again, we're not doing anything special here. It's just we put it in and ask the bank to calculate it another way. So now all I hit was second entry, by the way, that pulls up my last entry. So I don't have to type everything in. All I need to do is go in and replace all of the 2s with 4s. And you see quarterly, we are making $12,875.41. So as you can see, as we're doing this, obviously, the more frequently we compound these numbers, the more return on our investment we're going to get. So if you get to a bank, you want it to compound your interest more frequently. We're still getting 12%. It's just the manner in which we're getting 12%. And then the last one, $12,996.36. So over from annually to monthly is over $600 more. Again, I'm not doing anything differently. This is my money just sitting in the bank. It's just behaving the way exponentially is differently. And then the last one, continuous. Continuous compound is the best one we could do. This is $13,058.48. So this is what the difference between simple interest and our compounding interest. And we can compound these in different ways. Biweekly, daily. I mean, if you did daily, this number would be 365. This number would be 365. You're getting a very small percentage each time, but you're still getting it compounded more frequently. So let's take a look at this example we have here. Amy invests $5,637. Well, that definitely is my principal amount, $5,637. That's going to be equal to P. You can slide this over here. Parts we're looking for. A, we need the R, we need the N, and we need the T. So these are all the parts that are involved in this formula. We'll see how many of these are free and how many we need to work for. All right, and fixed annual interest rate of 6.23. I'm actually going to write this as a decimal over here. So the rate is 0.0623. And it is compounded 12 times a year. We could call that monthly, but that is our value N. And then the final question is, what would the account balance be after 7 years? So we know that T is 7. This is a nice friendly one. Anytime we're asked to find A, we just simply plug into our formula. So our formula would be, in this case, 5,637, 5637, 1 plus our rate of 6%, and we're dividing, forgot my 0, and I hope you use your common sense on this, because if I would have left that way, this investment would have gone way too high, way too fast. So we are getting our 6% divided 12 ways, but we're getting paid 12 times for 7 years. So this would be the equation that we're plugging in. Obviously, I'm going to need a calculator on this. So when I put this in my calculator, the answer that comes out is my investment is worth $8,708.71. And that seems reasonable. 7 years later, this investment is less than doubled. 12% interest, not a bad interest, so that number is reasonable. Had I left the 0.6 in the way I did, let's see what that would have come out to. The answer would have been $398,000. So, I mean, that's not reasonable. 7 years in the bank is not going to make it worth almost $500,000. So this example, let's go ahead and put our parts. We need a P, we need a rate, we need a number of times that it incurs, and we need the amount of time. Let's see what we got. It says, Catherine invests a sum of money in a savings account with a fixed annual interest of, well, there's our rate. So let's write that down, 0.0653, compounded continuously. All right, so this is going to be not an N, but this is going to be using Euler's number. So this is our PERT formula. After 4 years, the balance is $46.65 and 47 cents. What is the amount of initial investment? So we're missing the P on this. So we'll fill out our equation. 4665.47 equals our principal amount, which we do not know, Euler's number, which is not a variable, keep that in mind, to a 0.0653 times 4 power. Okay, so what I'm going to do actually is I'm going to put all of this in my calculator and get the decimal answer. Technically, if I wanted to be perfectly accurate as long as I could, I actually could just divide by 0.0653 to the 4th power. But I'm going to go ahead and change this to a number and work with that number. So Euler's number to a 0.0653 power times 4 is P times 1.2985. So this is times my P, so I'm going to have to divide. What I would suggest doing as well on this one is don't try to retype that number. Hit divided by in your calculator, scroll back up and bring down that solution, and it's going to give you an accurate reading. So once I divide both sides by this 1.2985 number, and what that means, by the way, is I've seen 29% growth on this one. Once we do that, I get the number $3,593.00. So there's my solution. All right, the next example we're going to look at, again, we're going to put our parts here. One thing I want to highlight, this is a continuous compounding. So that's that formula. I call it the PERT formula. We need the principal, the rate, and the time. So let's see, I'm going to put this over here and see what we've got. And remember, E is not a variable. E is Euler's number. It's like pi. It already has a number. So it says Stefan invest 4678 So that's going to be our initial amount. Fixed annually at a rate of 5 and 0.05%. So I'm moving the decimal place over twice. So that is 0.0505. And then we want to know how long it will take for him to get an investment value of $9,019.34. So the time is our variable, it's unknown. So we'll set up our equation. A equals the principal amount Euler's number to the rate 0.0505 times t, which is unknown. So anytime we have this set up, the first thing we want to do is divide by the number that's in front of E. So that's 4,678. We'll divide from both sides. So $9,019.34 divided by 4,678 is 1.928. All of this equals Euler's number. I need to leave myself a little bit of space here, because we are going to have to get rid of Euler's number in order to solve this. So let's think back to what we're supposed to do. When we're trying to find and reduce the value of Euler's number, remember we have to use the inverse function. And the inverse of Euler's number, hopefully you're thinking, that is the natural log. So we'll take natural log of both sides. Now, natural log and Euler's number just cancel one another. And this leaves us with 0.0505t. And natural log of 1.298 is 0.6565. And then I'm going to divide both sides by 0.0505. And that will finally get me t by itself. So the time needed, it ends up being 13.5097. So that's essentially 13, and we're talking about years here. So the time would be 13 years for this investment to be at $9,091, $19.34. And the last example we're going to take a look at is a compound interest that's going to compound 6 times a year. I don't even know if there's a number for this, but it doesn't matter because this is all formula based. So we're going to need to identify our parts, whether we have A, the starting amount, P, the principal amount, the rate, the number of occurrences, or the time. So these are the different parts we're going to see. So let's see and read what we've got. So Jasmine invests, okay, that's our P value, $6,647 into a retirement plan account with a fixed annual interest rate compounded 6 times per year. Well, that's going to be our N amount, which is 6. After 15 years, that is our T amount. The balance will reach $14,821.55. So the only part we're missing here of course, is our rate. So we're going to set up that formula, same formula we've been dealing with, which was the A equals P1 plus rate divided by N to the Tn power. So our ending amount, A, was $14,821.55. The initial investment is $6,647. 1 plus the rate, which we do not know, so we'll call that R, divided by the number of occurrences, in this case that's 6, to the N times T power. So that would be 615 power. So this is the equation that we have. So we're going to do the math that we can do on this. I'm going to rewrite this one, but I'm going to multiply that numerator, or exponent, excuse me. So it would be a 16 times 6 times 15 power, which is 90. And again, we're still looking for R. First thing we're going to do is divide by 6,664. I'll just tell you right now, most of the time that will be what you're doing when you're looking for rate or the number of occurrences. That will be what you're doing. So we're going to divide both sides by 6,647. When I divide this by 6,647, I get 2.2298. So now I have one plus the rate So we have a 90th power. What we've got to consider is, how do we get rid of powers? Well, the way we get rid of powers is with their inverse. Can we think about what the inverse of a power is? It is not a logarithm. That's how we get rid of an exponent. We're not trying to get rid of an exponent. We're targeting this power right here. So in order to get rid of a power, remember, we need to take the root. We are going to take the 90th root. What we do to one side, we have to do to the other. Now, this one can be done by hitting Math and looking at option 5. And that is how we set up a unknown power. And we take the 90th root of our number 229, my suggestion. Make sure that you just hit second copy that answer down. That's a lot to type there. So when I take the 90th root, I get this value. And in order to get the R by itself, the next thing I do is subtract 1. Well, we got a 1 right there in the front, so this is going to be 0.0089 equals R divided by 6. The way we get rid of it divided by 6 is by multiplying by 6. This question seems like a lot. The 90th root really throws you for a loop, but really, guys, this is just beyond that a regular arithmetic going on here. So what we end up with is 0.05369, so we'll call it 67. So let's go back and see. We were looking for the interest rate. Well, the rate is this, but we're going to write this rate as a percentage. So as a percentage, we need to move this decimal place over 2 spots, and we learn that our rate is equal to 5.37%. 5.37% is what the interest rate would be in order to get our investment of $6,000 to $14,000 6 times per year. All right, you have your assignment. You may work on that. Good luck.